Alright, so this is a continuation of what we were doing yesterday. You are still talking about slope. We're still talking about vertical and horizontal change. So remember that vertical means up and down, and horizontal means left to right. So the diagram at the right shows a chairlift going up a mountain. What is the vertical and horizontal change for each section? So we have section 1, section 2, and section 3. So the vertical change, remember, is how far it goes up. So from this point to this point here, it goes up 2. 1, 2. That's our vertical change. And then the horizontal change, it goes over 1, 2, 3, 4. So the horizontal change is 4. For the second section, the vertical change goes up 1, 2, 3, 4, 5, 6. And the horizontal change goes over 1, 2. In section 3, the vertical change goes up 1, 2, 3. And the horizontal change goes over 1, 2, 3. Now find the ratio of vertical change to horizontal change for each section. So that means that you are doing the vertical change over the horizontal change. So for section 1, that was 2 over 4, which is 1/2. Remember that we reduce these fractions, but we do not turn them into decimals or into mixed numbers because it is a ratio. Section 2, the vertical change was 6 over the horizontal change of 2, which reduces to 3 over 1, or you can just reduce it to 3. And the ratio for section 3, we had vertical change of 3 over the horizontal change of 3, which reduces to 1. Now, you may recall from yesterday that when we looked at the same line, all of the slopes were the same. And you may be wondering why these slopes are not the same. Well, this is not a straight line. For the slope to be the same, it has to be a straight line. It says put the ratios in order from least steep to most steep, and what do you notice? So steep, the more steep something is, the more straight up and down it goes. So that would be the most steep would be section 2. So that would be 3. So 1/2 for section 1, that was the least steep. It didn't really go up that much. It was 1/2, and then 1, and then 3. So we put these in order. And what do we notice? We notice that as the numbers get larger, the line gets more steep. Now, finding the slope or rate of change. Rate of change is another word for slope. Using a graph. It says the graph shows the altitude of an airplane as it comes in for a landing. Find the rate of change. So first, we find the vertical change, which we have said is what goes up and down. We always read, just like you're reading a book, you read from left to right. So we always start on the left point. So to find the vertical change, it actually went down 1, 2, 3, 4. But notice that this was not counting by 4s. It was counting by 250 each time. So this actually went down 250, 500, 750, 1,000. So the vertical change was negative 1,000 because we had to go down. And then we go to the right, and this is counting by 50s. So this is 50, 100, 150, 200, 250. So step 2, we found the horizontal change. And then step 3, write it as a ratio. In step 4, we will simplify. So we wrote it as a ratio, and now we can simplify. Negative 1,000 divided by 250 simplifies to negative 4 over 1, or just simply negative 4. And what does this mean in the context of the problem? That means that when the airplane is landing, it is going down -4 feet per second. Well, not -4 feet, but it is going down 4 feet per second. So the plane goes down at 4 feet per second. Now, finding slope using a graph. Choose any 2 points. Then you are going to find the vertical and horizontal change. In step 3, you are going to write it as a ratio. So it does not matter which 2 points that you choose to use on this graph. I'm going to use these first 2 points. So I find my vertical change, which is also known as my rise. So notice to get from this point to this point, I only had to rise up by 1. So my rise was 1 over my run, which was over 2. So to get from this point to this point, I had to go up 1 over 2. So the rise was 1 and the run was 2. Now they've broken this down into a more simple way to look at it. They took away most of the graph and just left the line. So in number 1, the rise would be 1 and the run would be 1. So that would be 1 over 1. In number 2, the rise is 2 and the run is 1. In number 3, the rise is 3, the run is 1. In number 4, you have to remember that we are reading from left to right. So if we start on the left side, you had to go down, so that is a -1, and then over 1. Number 5, again, reading from left to right, we had to go down 2, so that's -2 over 1. Number 6, left to right, means we're going down 3, -3, and then over 1. For the second row, number 7, you are going left to right, so we had to go up 1 and over 2. Number 8, up 1 and over 3. Number 9 is up 2 over 3. Number 10, left to right, we have to go down 3 and over 2. So that would be 3 over 2. And the understanding check at the bottom is for you to do. On the next page is more understanding checks. So now they've taken it and put it back in a graph. So remember, you find the rise over the run for each of these. The rise over the run for each one. Example 3, you are using the slope formula. So they gave you 2 points, and you need to find the slope that is passing through those 2 points without using a graph. So step 1, label your points. So this is x1, y1, x2, y2. Step 2, plug in to the slope formula. So remember the slope formula, m equals y2 minus y1 over x2 minus x1, and remember that m stands for slope. So I plug this in. That would be 7 minus 7 minus 1 over x2 is 6 minus x1 is -2. So 7 minus 1 is 6. 6 minus negative 2, we keep change, that is positive 8. So step 3, we simplify. 6 eighths simplifies into 3/4. So the slope of this line, if we plotted these 2 points on a graph, it would be a rise of 3, the rise of 3, and a run of 4. Now on the next page, at the top it says that slope, remember, is the vertical change divided by or not divided by, but sorry, it's a ratio of the vertical change to the horizontal change, which is also known as the rise over the run, or we can say y2 minus y1 over x2 minus x1. There are many ways to write this. So for all of these on 1 through 10, you are literally choosing any 2 points on the graph, write down what 2 points you chose, and find the slope between those 2 points. So this one is completely up to you to fill in and figure out. The last thing we need to talk about on the last part of this notes is horizontal and vertical lines. So notice this is your line here. So if I was going to rise to get from, so I'm trying to get from this point to this point, how far up do I have to rise? Well, I don't have to rise. My rise would be 0. And then how far over do I have to run? Well, I have to run over 1, 2, 3. So 0 over 3 is 0. 0 over any number is always 0. On the other hand, let's look at this line. So let's look at our rise over our run, our slope for this line. So you get from this point to this point, I have to go up 1, 2, 3, 4. And I have to run over nothing, just 0. But you cannot divide a number by 0. 0 cannot be in the denominator. This is undefined. So every time we have a horizontal line, the slope is 0. And every time we have a vertical line, the slope is undefined. And you'll notice on the little sideboard next to the calendar in my classroom, there are the words hoi and vux. Hoi stands for a horizontal line, has 0 slope, and we'll talk about the y at another time. And a vertical line has undefined slope, and we'll talk about what the x means at another time. So horizontal lines always have 0 slope, and vertical lines always have undefined slope. And then you can use your slope formula to finish filling out A through C. So remember that this is y2 minus y1 over x2 minus x1. Label all of your points and plug them in. So slope summary at the bottom of this page. A line with positive slope slants upward from left to right. So this would have a positive slope. A line with a negative slope goes down from left to right. A line with a slope of 0 is horizontal. And a line with a slope of undefined is vertical. So at this point, you should be able to finish the rest of the packet. Some of it is based on slope, and then the rest of it is based on other things that we have done so far this year.